Today we're looking at inverses of lines. We're going to start by investigating inverses. So let's take a look at what they look like when you graph them. Alright, so what do you observe when you look at the two tables? Hopefully you notice that all the x values in table 1 and all the y values in table 1 are switched in table 2. So the x's become the y's become the x's. The x's and y's are switched. Then it says to plot each table in order and connect them with line segments. We're going to use a different color for each table to differentiate between the two tables. Alright, for table 1, I'm going to use blue. So we have -6, -3, -8, 0, and we're connecting as we go, -5, 3, +5, 3, -1, 6, I didn't mean to make that dot, okay, and then 2, 9, and 8, 8. Okay. Now in a different color, I'm going to use green, -3, -6, 0, -8, 3, -5, 3, +5, 6, -1, 9, 2, and 8, 8. Alright, that's done. Next it asks, what is the transformation that has occurred between the two graphs? When you take a look at the blue and the green, it actually is a reflection. It's not a reflection over the x-axis or over the y-axis, but it is a reflection. Number 4, a line of reflection occurs between these two graphs. What is the line? Alright, so anytime you are finding the inverse of two things, two functions, anytime you do that, the inverse is a reflection over the line y equals x. Okay, this is the parent function of a line. And this will always be the case for inverses. Alright, so let's look specifically at the inverses of a line. Alright, so here I have -2/3, let me rewrite that, -2/3x plus 4. So -2/3 is the slope, +4 is the y-intercept. We're going to use this equation to complete a table. Okay, so one thing you can do is go into your y equals and type in -2 divided by 3 x plus 4, and then do the second graph button and it will come up with a table. Looks like my windows are set up. Okay. So I'm only going to pick a few of those points, the ones that are whole numbers. So I chose these points right here. I'm going to plot these points on the graph. Okay, so I have negative 9, 10, negative 6, 8, negative 3, 6, 0, 4, 3, 2, 6, 0, and 9, negative 2. And that's my first line. Switch the x and the y and graph the inverse. So I've switched the x and the y, and now I'm going to graph this. So start at 10, negative 9, 8, negative 6, 6, negative 3, we have 4, 0, 2, 3, 0, 6, and negative 2, 9. Okay, so we have an equation for the original line, a table for the original line, and a graph for the original line. We have flipped it over, y equals x, and we have a graph and a table. So how do you come up with the equation of the inverse? Well, one way is to do it algebraically. All right, so if you take your x and y and switch them in the table, you can also do the same thing for the equation. So our original equation is y equals negative 2/3 x plus 4. If I switch the x and the y and leave everything else exactly the same, I now have the equation of the inverse, but I have to solve for y. So that's easy enough to do. So what we're going to do first is subtract 4. So we have x minus 4 equals negative 2/3 y. And now to get rid of the negative 2/3, if I'm solving for y, I'm going to multiply by the reciprocal, negative 3 over 2. If I do it to one side, I have to do it to the other. So I have negative 3 over 2x. Negative 3 times negative 4 is a positive 12. 12 divided by 2 is 6. And on the right-hand side, negative 2 divided by 2 is 1, 3 divided by 3 is 1, and negative times a negative is a 1. So that's how I'm left with my y on the right side. So that's how you find the inverse equation algebraically. Let's try some more. All right, here I have f of x equals 2x minus 4. F of x is just function notation. So I'm going to change, my first step is to change f of x to y. It's the same thing. Function of f, the function of x, or y is the same thing. All right, that's my first step. Now I'm going to switch my x and my y. So I have x equals 2y minus 4. All I did was switch in the x and the y, and now I solve for y. So I'm going to add 4. Okay, now I've got to get rid of that 2, so I divide it. So I have 1 over 2x, and then 4 divided by 2 is 2. And there's my inverse function. All right, so what I want to do next is I want to go to my calculator. So this is the process I go through. I go to y equals, I type in my original function, 2x minus 4. go to the table, and I find some good whole number points. So I started at negative 310, and I wrote down a bunch of points there, as you can see. And then I graph it. Okay, that should be enough points for me to create a line. Now, the inverse. You could either switch the x and the y from the table and graph that, or you can type your new inverse equation into the calculator and find some points that way. Either method will get you the same line. And there you have it. Let's try one more. Okay, here again I have function notation, so I want to change that to y equals 1/3 x plus 1. It means the same thing. I'm going to switch my x and my y. And solve for y. So let me subtract 1 on both sides to get rid of it. Now I have to get rid of the 1/3, so I'm going to multiply by the reciprocal, which is 3, or 3 over 1. So I have 3x minus 3 is equal to y. If you like the y first, you could say y equals 3x minus 3. Graph the original function. Okay, switch the x and the y either in the table, or you can just simply in your calculator graph y equals 3x minus 3. And there you have it. You have found the inverse of a linear equation algebraically, using tables, and graphically. We will look at a warm-up, and then you will have some to do on your own.